When it comes to color measurement, it is very important to know what the essential site parameters are. Every application is different, and a calibration is required to achieve application-specific goals in a specific environment. Unlike standard physical variables, color has no defined zero point. This means that a calibration for each application must be based on defined goals. For example, processing speed, color or CCT accuracy, CRI optimization, or the compensation of external influences. If you have problems in defining the right calibration procedure for your application, MAZeT's team of experts is glad to assist you with design and support or extensive simulation options. For now, this guide will explain the main factors for calibrating the MTCS-INT-AB4 development kit and will guide you step by step through the process of calibration. Simply follow the installation instructions from the setup file. The software also requires to install the MATLAB runtime environment. MATLAB is a high-level language and interactive environment for numerical computation, visualization, and programming. This is used to provide the necessary computing power, for example for color coordinate calculations in various color spaces. Depending on the test software version, we use different runtime libraries of MATLAB. Please check our datasheets to install the correct runtime library. It is important to know that each application is different, and therefore calibration is required. The device offers an easy mode that can be used to initially test the system, for example, using a computer monitor. Keep in mind that these measurements are performed uncalibrated, and differences in accuracy can happen. This mode allows to perform simple measurements. Use the drop-down menu to change the output from ADC digits to color spaces to see how the color measurement is performed. The next steps will explain what needs to be considered during the application calibration and how to perform it. There are three main variables that need to be considered during a test setup during a calibration. These are the observer, the object, and the lighting conditions. When these three variables are known and optimized, the factor of gain in form of integration time and reference current depend on the light output and the environmental conditions. An ideal test setup where distance and the viewing angle of the sensor and spectrometer are equal is required. Make different tests to find an optimum between distance, object, light energy, and amplification. Make sure you have a stable test system and reduce environmental noise to a minimum. Reproducibility is an essential factor for successful calibration. By changing the site parameters step by step, for example by changing the angle of incidence, one can test the setup and adapt to specific application needs without unknown interferences. You should know all influences before you start with the calibration process. This allows stable values and high accuracy. The software of the MTCS-INT-AB4 allows various options for calibrating an application. There are the Expert and Easy mode. The calibration takes place in the Expert mode. You can choose between Command mode, Measure at Click, and Continuous mode. Depending on the application, you need to set up adequate integration time, reference current, divider, and offset settings. Please check the datasheet for further information and recommendations. With the ideal setup in place, the measurements can be performed by a 10 or 2 degree observer. The next step is to measure or import calibration targets. The user can choose the number of calibration targets and start with an offset, a dark measurement. The following step is to measure the chosen number of targets. After the measurements have been performed, one needs to import or enter the XYZ reference values measured by the spectrometer. A data file with the specific calibration information is saved and can be used for further reference. Changing elements, such as integration time or reference current, require a new calibration. Within the installation folder, you can find sample calibration files in form of CSV tables. The information gained in these tables can be used to address the microcontroller in your application and know how the MCDC signal converter processes the data. The CSV files consist of different columns showing the state, info register, info data, comments, read and write state, I2C address, register, and data. For example, the state column shows if the system is in the initialization phase or measurement phase. Info data and comments should help you to understand what is performed in these steps. For full details, check the datasheet for more information. The final three columns show the I2C address, the used registers, and address data. The data in these files is shown in the decimal system, but is later on processed in the binary system. MAZeT also offers design-in support and simulation options with in-depth tables to easily understand the system and perform the required calculations for an ideal calibration. With an application-calibrated device, it is possible to measure values and compare them to reference measurements. You can freely choose your diagram type to show what color or ADC values have been measured. The reference measurements allow to determine the delta margin between two color points or measurements. Therefore, accuracy comparisons are possible. There are several diagram types to choose from. Keep in mind that the MTCS-INT-AB4 does not have an included illumination source. Therefore, it is ideal for self-illuminated objects such as LED systems, monitors, or other displays. Aside the command mode, single-click measurements, there is the continuous mode. This allows to perform multiple measurements after another. It is able to monitor changes of color, CCT, or brightness in given applications. It is possible to turn off the diagrams to speed up the measurements. All measurements can be exported into Excel or CSV tables for further usage. If you have any questions or need support during your calibration process, contact us at any time. MAZeT's team of experts can gladly assist with design-in or other services, like calibration support, simulations, or optimization algorithms.